Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In a ring flip of a cyclohexane chair conformation, every axial substituent becomes equatorial and every equatorial substituent becomes axial. The relative stereochemistry, cis-trans relationship, is preserved, but axial and equatorial positions are interchanged. Moving on to the next step. Analyze the starting structure. The given chair conformation shows a desubstituted cyclohexane, appears to be 1,4-dimethylcyclohexane or a similar compound, where one methyl group is in the axial position, pointing upward, and the other methyl group is in the equatorial position. Moving on to the next step. Apply the ring flip rule. After a ring flip, the axial methyl becomes equatorial. The equatorial methyl becomes axial. The overall chair is inverted, flipped, so the formerly up axial group becomes a down equatorial group, and the formerly equatorial group becomes axial. And for the final step, evaluate the options. Option A shows a different connectivity or twist boat form, not the correct ring-flipped chair. Option B shows the correct ring-flipped chair conformation where the previously axial methyl is now equatorial and the previously equatorial methyl is now axial, with the chair drawing in the standard flipped orientation. This matches the expected outcome of a ring flip. Option C shows both methyls equatorial, which would require a change in stereochemistry, not just a ring flip. Option D shows both methyls axial, which also does not correspond to a simple ring flip of the given starting structure. Confirm. Option B correctly represents the ring-flipped conformer where axial and equatorial positions have been interchanged while maintaining the same connectivity and relative stereochemistry. Therefore, the correct answer is B. Therefore, the correct answer is option B.